Hi class, Mrs. Calvi here. We are going to be reviewing scale drawings and scale models. This is information on the screen here that you would want to copy into the notes section of your notebook. We are going to be talking about a scale drawing, which is a proportional two-dimensional drawing of an object. Now, its dimensions are related to the dimensions of the actual object by a ratio called the scale factor. So this right here, they give you a nice little example as to what that means. They're telling us that if a drawing of a building has a scale factor of 1/87th, this means that each dimension of the drawing is 1/87th of the corresponding dimension of the actual building. Okay? So when we have a scale drawing, basically what we're going to do is we're going to use a scale factor to find the actual measurement of the actual building. All right. We also have a scale model, and a scale model is a proportional three-dimensional model of an object. So a scale drawing is two-dimensional, and a scale model is three-dimensional. And they tell us a scale is the ratio between two sets of measurements. All right. We're going to go over examples that explain these, but this is something that you should be copying into the notes section of your notebook so you understand the difference between these. So remember, a scale drawing is two-dimensional. A scale model is three-dimensional, and we use something called the scale factor to actually calculate what the actual object measures. All right. So here we're going to go over how to actually find a scale factor. So in this example, they're telling us that we have a race car and we have a model of the race car. Now, you will hear me use the word actual a lot because that's what I use when I refer to the actual object. So like the actual car, the actual building. So not a model drawing, not a scale drawing. So here, the race car here, this is the actual, and I'm going to write actual above it. This is the measurements of the actual car versus the measurements of the model car. All right. So what we're going to do in order to identify the scale factor, it tells us here you can use the lengths or the heights to find the scale factor. So what I'm going to always do, I'm always going to do the model over the actual. You're going to want to keep this same ratio. So model over the actual. That's important to remember. So you're going to always remember that it's going to be the model over the actual to find the scale factor. So here I can either use the lengths or the heights. So I'm just going to go with the length. So the model length is 11. And the actual length of the car is 132. And here we're talking inches if we wanted to put our unit in. So now, in order for us to find the scale factor, we are just going to simplify this down. So we would simplify 11 over 132 all the way down, simplifying it as far as we can go. So if we were to do that, this is where knowing your facts comes in handy. We know that these are both divisible by 11, and that would give us 1/12. So here, the scale factor is 1/12, all right? So basically what that means is the model drawing or the model car, if this is a three-dimensional, the scale model is 1/12 the size of the actual, all right? That's what that's telling us, all right? So in order to find the scale factor, you're going to always take the model over the actual. So in this case, the model car was 11 inches. The actual car was 132 inches. Simplify that down. That gives us a scale factor of 1/12. Okay? And again, that means that each dimension of the drawing or the model is 1/12 of the corresponding dimensions of the actual car. All right? All right, so another thing we're going to be talking about is using scale factors to find unknown lengths. So let's go ahead and look at that. Okay, so here it says using scale factors to find unknown lengths. It says a photograph of Renee Marguerite's painting, The Schoolmaster, has dimensions of 5 and 4/10 centimeters and 4 centimeters. The scale factor is 1/15. Find the size of the actual painting. So here they're actually giving us the scale factor, and we're going to use that information to find the size of the actual painting. So here, these dimensions that they gave us, this is for the photograph. So that is actually for the scale drawing. So these are for the scale drawing, okay? So, and you can see that they have it worked out here. So kind of like how I talked about the scale factor, what they're saying here to think about this, the photo over the painting. So that means the model over the actual, right? So the model is the photo, the print, right? The photograph over the actual painting. So I'm just going to go ahead and write again, model over actual. Okay, so the model, let's see, the model length was 5.4 centimeters. So that's how they're getting the 5.4. And we don't know the actual length. That's what we're actually trying to, that's our unknown. We don't know what it is. And we know that it has a scale factor of 1/15. So we're going to make it equal to 1/15. All right. And if you notice, all they're doing here is they're cross multiplying. So 1 times L would give me 1L or just L. And then 5.4 times 15, if you did that calculation, you get 81 centimeters. So the length of the actual painting is 81 centimeters. So now we need to do the same thing for the width. Because the 5.4 was the length, we're going to do the same thing for the width. So we're just going to erase. And we know that the photo or the model was 4 centimeters wide. And we're going to over double. We don't know the actual width. That's what our unknown is. That's what we're looking to find out. And we know that there's a scale factor of 1/15. So again, we are going to cross multiply. 1 times W will just give me W. 15 times 4, that's going to give me 60. And we're talking centimeters here. So the length of the actual painting was 81 centimeters, and the width of the actual painting was 60 centimeters. All right. So here we use the scale factor that they gave us along with the scale drawing dimensions to find out how large the actual painting was, which was an 81 by 60 centimeter painting. Okay, so now we are going to do one more example. Okay, our last example here, we're talking about if we are looking at a map, and if you've ever actually seen a paper map, they will give you a map scale and they will tell you that in this case, every 3 centimeters is equivalent to 128 kilometers in distance. So here it says, on a map of Florida, the distance between Hialeah and Tampa is 10.5 centimeters. The map scale is 3 centimeters to 128 kilometers. So what that means is the 3 centimeters is the model, and the 128 is the actual. So for every 3 centimeters on the map, that is equivalent to 128 kilometers. They're asking what is the actual distance D between these two cities. So if we're looking at this, we know, again, we are going to do model over actual. If you constantly keep this ratio, makes it easier. So the model on the map is 3 centimeters, and that actually relates to 128 kilometers, right? Okay, so now we want to know what the actual distance between the two cities are. And they gave us the additional information that the distance on the map is 10.5 centimeters. Well, that's the model distance. We want to know the actual distance. So we are going to set up a proportion of 3 centimeters to 128 kilometers. So remember, my numerator is my model, my denominator is my actual. I do not know my actual. That's what we are solving for. So that's going to be my variable. And my numerator, the model is 10.5 centimeters. So now to solve, we are going to just cross multiply. 3 times d gives me 3d. 128 times 10.5, that gives us the 1,344. And you know to solve, you're going to divide by 3. And the actual distance from Hialeah to Tampa is going to be 448 kilometers. Okay? Pretty simple, not so bad. And that is it for today. I will talk to you guys soon.